Hello everyone. Today I am going to discuss about the emulsions. Emulsions are nothing but biphasic liquid dosage forms consisting of two different phases, aqueous phase and oily phase. So it is mentioned under the category of biphasic liquid dosage forms. Coming into the topic, coming to the definition of emulsions. Emulsions are thermodynamically unstable disperse systems. Since these contain two different phases, we are calling emulsions as dispersed systems. These are thermodynamically unstable. So it is a biphasic liquid dosage form consisting of two immiscible liquids. One is dispersed in the form of droplets and the other is dispersed as a continuous phase. So and these emulsions are stabilized by an emulsifying agent. Since the two different phases are there, we can say emulsions as a heterogeneous mixture of two immiscible liquids. One liquid is called as dispersed phase, which is dispersed in the form of small droplets, and the another liquid is called as continuous phase. Classification of emulsions. Examples are oil in water emulsions and water in oil emulsions. In first category, oil in water emulsions, oils are acting as dispersed phases. They are in the form of small droplets, and water acts as a continuous phase. Whereas in water and oil emulsions, water acts as a droplets as a dispersed phase, and oil is acting as a continuous phase. And one more special category is there in the emulsions, that is called as multiple emulsions. Oil in water in oil, and other one is water in oil in water, and they are having specialized applications in the market. So see, as I have earlier said, these emulsions are, since they contain two immiscible liquids, they are stabilized by emulsifying agent, and those are also called as emulsifiers, and they are used for stabilizing the emulsions, because the definition itself we have said those are thermodynamically unstable. So to make them stable, we are adding emulsifiers. They are categorized as surfactants, proteins and polysaccharides. What does the emulsifiers do? Their mechanism of action is they form a thin film around the globules so that they reduce the friction or surface tension between the two immiscible liquids. So as I have said, it forms a thin film as a protective layer around the dispersed phase, so by which the friction between the particles will be reduced. So we can say it as a reduction in the surface tension, thereby preventing the coagulance or fusing of the droplets. This is the mechanism of action of emulsifiers. So since we are saying emulsions as dispersed systems, the Latin word is disperger, means to remove or to redistribute and the other terminology in Latin is emulger. Emulger means it may be emulsion or it may be a suspension. Suspender, it is a Latin term, we call it as to keep in or to keep in floating. Examples of the emulsifiers here include are lecithin, sodium lauryl sulfate and polysorbates. These are playing a vital role to stabilize the emulsions. Either it is used in pharmaceuticals, cosmetics and several food products. So what is the function? As I have said, that will reduce the surface tension between the two different phases, and it will stabilize the emulsions, and it will improve the texture and consistency of the emulsions. How we have to select the emulsifying agents? Based on our preparation, based on the compatibility between the ingredients, we have to select the emulsifying agents. Based on the stability of the emulsions, to prevent the phase inversion. Suppose we are preparing oil in water. So due to instability, what happens? Instead of oil in water, we will be getting water in oil. So to avoid that, we have to add these emulsifying agents. But based on the safety, based on the cost effectiveness, we have to select the emulsifying agents. So what are the ideal properties of the emulsifying agents? First and foremost thing is should reduce the interfacial tension between the two immiscible liquids. It should be physically stable, chemically stable, inert, and should be compatible with all other ingredients present in the formulation. It is non-toxic, non-irritant, and it should not impart any color, order to the preparation. It should maintain the viscosity of the preparation properly. It should form a coherent film as a protective layer around the globules of the dispersed phase and prevent the coagulation of the droplets of the dispersed phase. So this is the general classification of the emulsifying agents: natural, semi-synthetic, synthetic. Natural is from vegetable source or animal source. Examples are like agar, tragacan, pectin, etc. So emulsifying agents from animal sources are wool fat, gelatin, etc. Then semi-synthetic emulsifiers, the methyl cellulose or carboxymethyl cellulose, they are cellulose derivatives. Then synthetic emulsifying agents are categorized as anionic, cationic, non-ionic and inorganic. Anionic most famous one is sodium lauryl sulfate. Cationic is benzalkonium chloride. Non-ionic is glyceryl ester, and milk of magnesia is an inorganic emulsifying agent. So these are the examples. As I mentioned earlier, proteins are used as emulsifiers, carbohydrates, etc. So the natural emulsifying agents like agar, acacia, tragacan, these are used as carbohydrate materials, and these are used to prepare oil in water emulsions. If we are using proteins as emulsifying agents, we will try to prepare oil in water emulsions. Some of the examples are gelatin, egg yolk, casein, etc. And some of the high molecular weight alcohols are also used as emulsifiers. Examples are stearyl alcohol, cetyl alcohol, glyceryl monostearate. These are used to prepare oil in water emulsions. If cholesterol is used, it is used to prepare water in oil emulsions. Wetting agents, this comes under the category of synthetic one. So that's why classification is given as anionic, cationic, and non-ionic. And we will be trying to prepare both oil in water and water in oil emulsions. Finely divided solids, it comes under the examples of inorganic synthetic emulsifying agents. Examples are bentonite, magnesium hydroxide, aluminum hydroxide. We will be maximum trying to prepare the oil in water emulsion. Next, coming to the mechanism of action, as I have said, these emulsifiers, they form a thin layer by absorbing to the surface of either oil particles or water particles. If surfactants are used, they form a micelles that prevent the coagulation of the droplets. And if they act as a physical barrier to prevent the droplets from merging. How we can determine the emulsion type? So there are several methods to determine the emulsion type. First test is dye solubility test. For this we will be taking the water soluble dye like methylene blue and brilliant blue. Any of this we will be taking. And if the water is an external phase or continuous phase, how the color of the emulsion will be? It may be either a blue color of methylene blue or blue color of brilliant blue, by which we can say that water is present in as a continuous phase and oil is present in the dispersed phase. If it is a W/O type of emulsion, the water particles will observe as clumps or agglomerates. Okay, if water is continuous phase, it will be a form of solution. If water is in a dispersed phase, the emulsion will be in the form of a droplets or in the form of a agglomerates. Okay. The next one is dilution test. We will be diluting the emulsion with water. If water is a continuous phase, we can say with the emulsion looks clear in the emulsion in the water. Water will be in a more continuous phase, and water will be easily mixed up with the emulsion, which is in which the water will be in a continuous phase. If it is a other type, that means water in oil emulsion in which oil is a continuous phase, so there will be a cracking seen in the emulsion. Since we are using water for dilution, O/W type of emulsions will be good in appearance, whereas water in oil emulsions, they show some problem called as cracking of emulsion. The next test is conductivity test. As we know, when water, electricity will be produced. Based on this concept, conductivity test is done for emulsions. If oil and water emulsions are there, light will be produced or light will be glown. If water and oil emulsions are there, the glowness of light is somewhat dull or failure when compared with the oil and water emulsions, because water is present in more amount in oil and water emulsions, so light will glow, whereas in water and oil emulsions water is present in small amounts, so there may be the failure of light to glow. Then other two tests are cobalt chloride test or filter paper test. Here filter paper is taken, it is impregnated with the cobalt chloride, it is dried. If color changes to pink in color, we call it as oil in water emulsion. Okay, then fluorescence test. Some oils generally they glow, they give fluorescence if some UV light is exposed on it, while water do not give any fluorescence, and so that by which we can say that since water do not give any fluorescence, how the emulsions look, they give a spotty pattern. And here in water and oil emulsions, oil is present in continuous phase, so more glowing or more fluorescence is observed in case of water and oil emulsions. Next, how to prepare these emulsions. There are several methods, out of which two methods are famous: dry gum method and wet gum method, and miscellaneous methods we can say as bottle method and mechanical method. In dry gum method, we will be taking mortar and pestle. To that we will be adding the emulsifier. One part of emulsifier we will be adding, and 4 parts of oil we will be adding, and we will be thoroughly mixing. Then finally we will be adding the water. So here the proportion to prepare the primary emulsion of oil is to water is to gum is 4:2:1, and we have to triturate in such a way that until a clicking or crackling sound is observed. Wet gum method, it is also called as English method. Here one part of gum mixed with 2 parts. So here it is reverse. Here in dry gum method, we have added water at last. In wet gum method, we are adding water in the front, in the initial only. Then we will be trying to prepare the emulsion. Bottle method, it is also called as Forbes method, and this method is used to prepare the emulsions which contain volatile oils. And the part of this is 2:2:1 for to prepare the primary emulsion. Oil is to water is to gum. Okay, whereas in mechanical method, here it is used in industries where large equipments are used for proper mixing. Mixing equipments we will be using here are colloidal means hydrogen homogenizers, blenders, because it is prepared in a large size and to produce stable and fine droplet emulsions. Then comes here the problems related to the emulsions. As I have said in the methods to determine the emulsions, if water is added more, in case of W/O emulsions, there will be cracking or cracking of the emulsion occurs. So it is one of the problem that is seen with the emulsions. Here separation of two layers, cracking means what? Separation of two layers is observed. Why the separation occurs? Due to agglomeration of the particles, and once we shake also the particles may not distribute uniformly. So the reasons is if emulsifying agent is not added of a correct concentration, or if you have added opposite type of emulsifying agent, or even improper selection, good quality is not used, good quality of emulsifying agent is not used, and if they are not properly stored, if there is change in temperature by creaming or by addition of some other solvents also, that will lead to the cracking. Then flocculation, it is flocculus means small globules, that's why we are saying it as droplet aggregation. In next figure we will be coming to know, and these droplets are formed due to the attraction or interaction between the droplets, that is called as van der Waals forces, due to which they get agglomerated. Since van der Waals forces are weak force, once we release first, once we shake the preparation, it will again form a homogeneous emulsion. If you see the figure, see this is a good emulsion, and in case of creaming or cracking or breaking, what happens? So cracking is also called as breaking. Separation of two layers is observed. In flocculation, see small globules are occurred, so this is called as droplet aggregation. Okay, whereas in cracking it is difficult to form a homogeneous mixture on shaking, whereas in flocculation it is possible. The next type of problem is creaming. It is called as droplet migration. It is called as droplet migration. That means the particles which are dispersed, they will move to the top of the surface and form a thick layer. Okay, and that will lead to the cream type formation. So why cream is formed? Due to the droplet migration from inside the solution, inside the preparation to the top surface of the preparation. So it is a temporary one. Once we shake, once again it will come to a homogeneous preparation. So the creaming is described by Stokes' law, okay, which will tell why the upward movement of the dispersed globules is observed. So this is the formula: V is equal to 2R square D1 minus G2 into G by 9. V is the rate of creaming, radius of globules, density of dispersed phase. D1 is density of dispersed phase, D2 is the density of the dispersion medium, gravitational constant, viscosity of the dispersion medium. See here, to what extent the creaming is happened is calculated by the Stokes law, and since the upward movement of the particles is there, it is against the gravity, so we are taking the gravitational constant also here in case of in case of calculating the rate of creaming. How the creaming is reduced? By using the homogenizers, or by increasing the continuous phase, by matching the density of the dispersed phase to the continuous phase. We will be trying to decrease the problem of creaming. The next problem is phase inversion. So O by W cream emulsion may be changed to W by O due to some incompatibility problems. So why this happens means due to the addition of electrolyte, due to the change in the phase volume ratio, by temperature changes, by Emulsion changes, this will happen. So to avoid this, we have to keep the concentration of the dispersed phase to 30 to 60%, and it should be stored in a cool place, because high temperatures will lead to phase inversion, and we have to select the emulsifying agent properly of adequate concentration. So on one more problem that occurs with the emulsions is droplet merging. Means agglomerates are formed, or fusion of the smaller particles will be done. So by which the surface area will be reduced and emulsions may not be formed properly. So see here different problems. This is good emulsion. This is phase. See here, yellow globules are small and water is a continuous phase. See here, phase inversion. Water became the dispersed phase and oil became the continuous phase. Yellow means oil here. Okay. So this is agglomerates flocculation. This is the settling down of particles called as sedimentation. And creaming, see some cream is formed at the top. Pollens is big size particles are formed. So these are the different problems occurs with the emulsions if not done properly.